All right, in this lesson, we are going to learn how to solve the AND compound inequalities. So we have two goals. First goal is I can solve an AND compound inequality. And the second goal is I can graph an AND compound inequality. So we have these two different goals for today. So let's take a look at some of our vocabulary. An AND inequality is an intersection. It's a compound inequality that is true only if both inequalities are true. So like a real world analogy would be to ride a roller coaster, you must be at least 48 inches tall and you must have a ticket. Do you only need one? No, you have to have both conditions. You have to be taller than 48 and have a ticket. Okay, unlike the ORs, where you just had to have one of them be true. So once again, we're going to be looking for boundary points. These are our critical values. Remember when it's a less than, oops, that's not what happened. There we go. Remember if it's a less than or an equal without an or equal to sign, right, like these, it's an open circle. If it does have an or equal to sign with it, it's going to be a closed circle. So we're going to use boundary points, and we got to know whether they're open or they are closed. So let's take a look. Here's some helpful steps for you. There are typically three parts to these inequalities: a left part, a middle part, and a right part. We need to perform inverse operations to isolate the variable in the middle. So for example, if we have -5 is less than or equal to x plus 7 is less than 3, -5 is the left side, x plus 7 is my middle, and the right side is 3. And we have to isolate whatever's in the middle. So in this case, I would subtract a 7. And usually we do it, whatever we do to one side, we do to the other. In this case, we technically have 3 sides. So we're going to do it to all 3 of the sides whenever we do something to any of them. Okay? So that's basically what that all says. So when solving equations, whatever we do to one side, we must do to the other side. It's the same, but we have 3 sides. And then when we graph it, we're going to find our boundary points. And then we're going to shade between the boundary points this time instead of going in opposite directions. So let's take a look at an example here. So we got -10 is less than x minus 6, which is less than or equal to 0. So our goal is to get this by itself. So in this case, I have to add 6, which will make it cancel out, but I have to add a 6 here, and I have to add a 6 here as well for it to all stay true. So -10 plus 6 is -4. Bring down your sign, less than. We have an x, because it stayed there, less than or equal to 6. Okay, the x is now isolated, so we are done. We've solved the compound inequality. Now let's go ahead and graph it. So remember, to graph it, we're going to use our boundary points. So -4 is a boundary point, 6 is a boundary point. So we're going to start with a -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So -4 is open because there's not an or equal to sign. +6 is filled in because it does have an or equal to sign. And then we shade between the two problems. So to be able to, the solution to this inequality could be anything between these two numbers, including the number 6. So it could be a -3, -2, -1, etc., all the way up to 6. Okay, let's try this one. So we're just focusing on our middle x. We want to get that by itself. It's being divided by 3. So the inverse, or the opposite of divide, is we're going to go ahead and times by 3. And that will cancel each other out. Since I multiplied the middle by 3, I have to multiply the right by 3 and the left by 3. So 3 times -4 is -12. Less than or equal to, the x is still there, less than -2 times 3 is -6. And there I have solved the compound inequality. We have boundary points at -12 and at -6. So we're going to put negative 12, negative 11. And remember on your assignment, these will all be filled in for you. The numbers will be. So, boundary point at negative 12, and it is closed because we have an or equal to sign. Negative 6 is open because we do not have an or equal to sign. And then shade between them. Really straightforward. Just find your boundary points. Make sure you get the open or the closed circle and shade between them. Let's do another one. This time we have a two-step equation in the middle. So we're going to have to do two different operations to our middle term. So first, we're going to add 2 to everything. Negative 2 plus 2 disappears because it's a 0. 7 plus 2 is 9. It's less than 9x is less than 88 plus 2 is 90. All right, now we have that 9 times x. So we're going to have to divide by 9. Whatever I do to one term or one side, I have to do to all of them. 9 divided by 9 is 1. The x stayed in the middle. 90 divided by 9 is 10. So now I have solved my compound inequality. Let's go ahead and put the numbers on my number line. Okay, my first boundary number is at 1, so we're going to circle. And it is open because there is no or equal to. Second boundary number is 10, circle, open because there's no or equal to sign. And we just shade between the two. And there is my graph for my compound inequality. Okay, but remember when we talked about it last time, what happens when we divide or multiply by a negative? Sign has to flip because the sign of the number changes as well. So let's do this last example. Take this 11, we're going to minus it from all three sides. So it cancels out there. 29 minus 11 is 18. Less than or equal to negative 2x. Less than or equal to 33 minus 11 is 22. All right, now we need to take care of that negative 2. Let's go ahead and divide by the negative 2, and it cancels out because negative 2 divided by negative 2 is 1. So that's why our x survives. Divide by negative 2. 18 divided by negative 2 is negative 9. 22 divided by negative 2 is negative 11. Since I divided by that negative, this less than or equal to is going to turn into a greater than or equal to. This less than or equal to is going to turn into a greater than or equal to. Now you might notice that these are a little different than everything we've done before because now my signs are facing the other way. So to make this easy, we're just going to take this whole thing and we're going to flip it like a pancake. So negative 11, we're going to write that first. So we're flipping everything. And so the greater than or equal to will flip back to a less than or equal to. X stays there. This sign's going to flip to a negative or a less than or equal to. And then the negative 9 will come. These two things right here, this and this, say the exact same thing. It's saying x is between negative 11 and negative 9. Once again here, it's saying x is between negative 11 and negative 9. Technically, you could write down your answer either way and get it correct. We're just used to seeing it like this, not like that, but they're both the same. Mathematically, they're saying the same thing. So let's go ahead and write our boundary point down at negative 11. We have a boundary point at negative 9. They're both going to be closed circles because they have a less than or equal to, and then we just shade between them. And so those are my possibilities to be able to solve this particular compound inequality. So anything between negative 11 and negative 9, including those numbers, would be a solution. So let's review our goals. I can solve an and compound inequality. That's what we did up here. This was solving. And then our second goal was we can graph it. That's what we did down here. So those were our two goals. Now I want you to go and practice on your assignment to make sure you can really understand how to do these. Please reach out if you have any questions. And I'm going to add a video again just so you can see what it looks like on the actual assignment.